Well, students, welcome to the lecture number 44, where so far we had discussed about the various types of spraying equipment which are available to in the different locations and the textbooks, etc. You might have seen. We discussed all the gamuts, all the facets of that and all the features. We talked about the sprayers, the nozzles, their other details, everything we have discussed. Now, we will discuss certain advanced level equipment which are available, and this particular equipment in fact is one which is used in a practical situation. In fact, what happened that in Maharashtra there are pomegranate orchards, and in those orchards there was a problem that whenever there is some insect or pest attacked onto the orchards, the sprayers available are that they continuously, once the tractodon units are available, and once they are started, they will keep on completing the operation, they will not stop in between. So, irrespective of whether the pomegranate plant is there or the canopy is there or not, it will continue. Now, this way lot of chemical or the actual cost of the chemical as well as the time taken. So, we lost a lot of chemical. So, this problem was given to us at IIT Kharagpur to find out what can be done, so that we only apply at the canopy at the required target, and we do not require at the other place. So, this became a challenge. We had to do lot of background work by going over there in Rahuri in Maharashtra, and we did this work. So, I would like to tell you how we proceeded for this particular device, which is the ultrasonic sensor. We use the ultrasonic sensor for doing this particular job, and we achieved a reasonably good level of success on that. So, let us go through the slides which I have brought for you. Need of advanced level. Well, the existing why advanced level, as I said that this is a problem which was already given to us. So, we have done in the existing system there is no cutoff, that is what you see, the system which are available there is no cutoff. That means to avoid spraying between the plants, in between the plants. Then, so more than 50% of this chemical or this insecticide or pesticides or fungicides is wasted unnecessary. It should be only applied at the target where it is required. Now, this and so this very requirement is as enough to justify that you must go for a upgraded information based technology which will save this chemical, and that is how we launched on to this particular task of designing ultrasonic sensor based sprayer. What we had taken is, we had taken the sprayer which is the concepts which are already there with us. That means, there should be a tank, there should be a pump, and there should be delivery tube and things like that. But then how to coordinate all these things, how to have a sensor which will go in front and then inform the system to switch on and off. So, this is what was done. So, the working principle of this ultrasonic sensor based sprayer, what is the working principle here? Based on the object sensing, it's this ultrasonic sprayer system, ultrasonic sensor, if it finds a object in the in its path, then immediately it reflects, and then that concept, a principle of that is utilized. So, ultrasonic sensor generates high frequency sound waves and evaluate the echo which is received back by the sensor. So, this is the concept of ultrasonic sensor. It generates high frequency sound waves, and then the echo is received back by the sensor. So, that means it knows that where is it and how far is the target. So, depending upon the distance that you maintain for the target and the unit, you can know that what sort of timing you should fix, so that by the time the target reached, when you are moving into the row to row spacing, you will find the target exactly at that location. This is the challenge to be designed. So, nozzle stops spraying if the plant is not present. That means, the moment it will say that it has located the target, it will spray. If it has not located the target, then it will not spray. So, there is no wastage, this is what the concept. So, concept is nothing but ultrasonic sensors which will have which have high frequency sound, and then they receive back the echo, and this is the one which talks of which crux of the whole aspect of design. How do we plan this? What should be the distance, or what distance it should be fixed, so that it reaches to the target, gets the information, and then feeds it back to a controlling system, a system which will deliver this information back to the pump, and then to the details, and ultimately it will be to the nozzles, and then to the spraying system. So, this is what has been thought of in the ultrasonic sensor. Well, I said that a lot of work we had to do while we went for this particular task, because we need to know what is the canopy size, what is the spacing between the different plants of the pomegranate, and what is the total vegetation that we get, how they are planted, and things like that. Background information was very important. So, people went there and got this background information about the plant, its genetics, its details of morphology, and all details, and the growth rate, and its total spread of the canopy, etc. So, here just concept is here that a microcontroller is here in this. You can see here that there is a ultrasonic sensor which is kept over here, and there is a microcontroller here. So, now these two will try to synchronize and try to do the job. So, the sensor will give the information, and then microcontroller will try to process the information, and then try to inform to the other systems in the process. I will come to that later. So, a small prototype was made. Now, what are the details of this prototype? What will be there? You know that the moment you are talking of a spraying system, you have to have the location where you should have the liquid. So, a tank or a holder where you are holding the tank, the liquid. So, this is the tank here, this is the tank is given here. Then the nozzles, where are the nozzles? Okay. So, you can see that these are the details of the pipes, and this is the nozzle over here. Then where is the solenoid? Where is the solenoid? Now, why is solenoid? We wanted to regulate this information very precisely. So, we have got this electrical solenoid valves. So, these valves will help you in precisely doing the job which was informed to it. And now, this there is a frame created, for attaching this system, Now, these are the other details. You can see here that the sensors, there are sensors here put here. That means the sensors are on two sides of this. When the system is going in, they are on the two sides, and this is the complete frame here. This is the complete frame here on which the whole thing is connected. So, and this is a pump. This is a pump which is connected here. This pump will be operated by taking power from the PTO. So, you can see here the through the universal joint we are joined the PTO, and from here you can see that this is the power which is transferred. So, in this we are transferring the power from the PTO to the pump. So, the pump runs. So, once the pump runs, the delivery is available to you. Now, how to transmit that availability, when to do it, how the process moves. As I said earlier, that we need to know where is the target. So, that is done by this ultrasonic sensors. So, this if you talk of this, which is on this side, the other one is the other side. So, if this, so this will in fact first identify the target. The moment it identifies the target, you can see that this is at a distance of this from here. This is nozzles are here, and this is at a certain distance. So, we need to maintain this distance. Generally, this distance varies between 2 to 3 meters or so. So, depending upon what is the type of the sensor, generally within 3 meters we would like to keep the sensor and the nozzles. And we also need to match the speed of the tractor. Now, this is the you cannot see the tractor. We will show you in the demonstration, another video will show you where you can understand and then appreciate that how this target is identified, and accordingly the speed is controlled in such a way that by the time it has reached there, the spraying starts and it stops the moment we cross that. So, this is the preliminary system, the first system, the base system which we had developed initially. Now, this system, in fact, we carried this system, we did some preliminary testing at IIT Kharagpur, and after that we had taken this system to Rahuri in that particular location there to test whether the type of the nodules which we have used are perfect or not, the system that we have developed is okay or not, and the amount of chemical which is to be thrown or which is to be sprayed is all right or not. So, this unit was then transported several hundred kilometers to Rahuri in the pomegranate farm for testing. Some more details. Well, block diagram of the ultrasonic sensor based spraying system. Certain details we have given you here. Well, you can know that these systems are designed and they are IPR protected. So, but then it helps you to understand that IIT Kharagpur has developed this system, and in fact, there are manufacturers who are interested to take this unit for use. Now, you can see here, you can see the sensor 2 here, sensor 1 here on the two sides. Then you can see the spray nozzle here, then you can see the spray nozzle on this side. Then you can see here solenoid valves. These are the solenoid valves which are there. This is one solenoid valve, this is another solenoid valve, these are the solenoid valves. It's talking of the pump here, this is the pump here, then there is a safety valve here, this is the tank. So, this talks of the pump, the operation of the pump. Now, if plant is detected, you can see here that if plant is detected here, then there is a relay switch. Accordingly, it will inform to the spray. If it is not, then it will go back and processing the data which it has received from the sensor. So, the same thing is being done for the other side also. This is the microcontroller. So, initial in and out pins means microcontroller is the one which has been designed, and that processes the information and delivers to the through the solenoid valves to the nozzles, and then the nozzles do their job. Now, we have put this system has been shown only a single nozzle on both sides, just a representative one. But then when you have a canopy and when you want that to be spread into a particular canopy, you should know that the canopy must be completely drenched. Otherwise, the insects which are there will not be affected. Maybe only 50% of the insect infestation will be controlled, the others will not be. So, therefore, you have to orient these nozzles in such a way, you have to plan the location and orientation of the nozzles and the boom which we are talking with respect to the canopy in such a way that you are able to spray the liquid, whether it is insecticides or pesticide, whatever, or fungicide, to control into the whole sensor. Now, this side is the details of the circuit which is given, circuit diagram of the spraying system of the same thing, which are all details are given here. On this power supply is given here, the ultrasonic transducer is here, then inlet outlet solenoid valves are given here. The other details, all details of the battery, etc., everything is given over here. So, with these this slide I want to show you that these are electrical circuits and these are the block diagram of what we are doing, how we are doing, a conceptual way which you can appreciate that yes, it is possible to do this. Maybe that this will give you information which you can think of doing something better and much better than what we have done, or you can improvise on this system itself and get better efficiency of the system and so on and so forth, depending upon if you can understand what is the concept which has been tried to explain over here. Now, the testing, as I said that this unit was taken in Rahuri there, Rahuri, Maharashtra, which is in Maharashtra, and this unit was explained in front of the farmers, the directors of research and all these people, and in fact we had measured the deposition efficiency, etc., all details. So, we will just show you how it operates. Just have a look at this. You can see, you will be able to see here that wherever there is a plant, it is spraying, and when there is no plant, the spray is not taking place, and these are on both the sides. You can have a just look, yeah, you can just look at the performance, the way it is doing, and see the way the whole nozzles have been oriented. The nozzles have been oriented just on the in such a way that from below, from the middle, and from the top. So, from all the three orientations, the whole plant is drenched, and then this is from one side. When you get back to the other side, again you can find that this will be there. You can see these are some of the photographs which indicate that yes, this unit was tested at that location. We got certain performance observations which they said, and those observations were with regard to the nozzles, with regard to the speed of operation, and with regard to the orientation of the nozzles, etc. And then what we did, we in fact brought back the unit at IIT Kharagpur again, and then we changed the nozzles, we changed the orientation, perfected again, and then we took it back and tested there in front of the people and the farmers, and they found that this unit is working very well, and this unit ultimately saves lot of chemical. So, you can see another unit what we have. So, we wanted that this unit, a air assisted sprayer. Now, air assisted sprayer is available in the market. So, we wanted to see if we can attach the one system which we have developed. So, if we have developed such system, we would like to check this, and in fact, we did it, and you can see here that the chemical chemical losses and drips, etc., can be minimized. Okay. The using ultrasonic sensor they developed at IIT Kharagpur, and in fact, in this what we call retrofitting, because this is available in the market and we have purchased that, and then we have fitted our system into this. So, you can see the operation. We will see that both the units, when the unit was not connected, on one side we have the air assisted sprayer which is not connected with our system, and the other side which is connected with the ultrasonic sensor. So, you see the operation of that, and then you will be able to appreciate that the system is really working well. So, you can have a look at this. You see that on this side, this is here, you can see that only one side is spraying, because the other side, since the canopy is not there, it is on the road. So, we wanted, you can have a look at this, that it is just spraying on the plants wherever, and here you can find the on their side which was there, it is simply throwing all over, and this is the problem with this, that you are not able to save so much of chemical, you will have so much of volume of material you have to create, and you will lose about 50% of that. So, with this unit, we are in a position to save about 45 to 50% of the whole chemical which we have at this location. You can see that these are the systems which are available here. You can see here, whenever there is yes, there are certain modifications. In fact, this is the first prototype, and you can say that initial trial which we are doing after fitting this system, which is ultrasonic sensor, which is developed at IIT Kharagpur. So, there could be some initial hiccups, and we need to change the orientation of this, we need to direct the orientation of all these things. In fact, we also need to maintain the pressure, etc., and maybe size of the solenoid valves. We observed certain of these aspects which we wanted, and that is why we are confident that this system, the ultrasonic sensor system which has been developed, is worth having system, and it will save the chemicals, and definitely it will be better for the farmer. So, the cost of application will come down. Now, we wanted to compare certain values with respect to this here, laboratory test data and modified sprayer here, field test data of modified sprayer here. So, in the laboratory what we got, see this is important because until unless you test this under laboratory and the field conditions, you may not be in a position to appreciate what we have got. So, laboratory test data of the modified sprayer and field test data of the modified sprayer on two sides. You can just have a look at this. See at the pressures, when we are varying the pressure, when your pressure is 400, the discharge is this, the nozzle angle is this much and the overlap is this. Now, accordingly, as you are increasing the pressure here, the discharge is changing and the nozzle angle is also changing here. At the same time, overall overlap. Now, what is important is when you are using such units, the designer or the engineer has to go in details of how to fix what is the location of the nozzle, what should be the height of the nozzle, what should be the spray angle of the nozzle, how much of the overlap that we want to put and all that. So, these details are very important when you are doing the modification, you are doing the testing or you are doing the design of the such systems. So, you can see here that as the pressure increase from here to here, the overlap is also increased. So, now what is important is if the size of the location at where the nozzle is kept is remaining same, then in order to match this you have to have, you can't have varying. So, as the pressure increases, this should not be like this. So, depending upon what you want to have and how you want to have, this is important for a laboratory testing. Now, in field test we have all the details which are given because it has engine, the tractor model and all this which we had tested. So, all these details are given, at what variety was utilized and what is the discharge rate, what is the pump pressure which we had followed and what is the chemical saving. So, in fact, this is one which is very important. We could save about 45 to 50% of the chemical in this system which we had done. So, the modified sprayer, with the sprayer when we purchased from the market, we modified it with our ultrasonic sensor and then when we compared, we found that about 45 to 50% of the chemical you can save. So, through this lecture what we wanted to inform to you that there is need for use of sensors and artificial intelligence knowledge into the design of the equipment, which will help us in minimizing the inputs, which is the requirement in fact, because as you know that as the area is decreasing, the land is decreasing, but then population is increasing. So, we need to feed more and more, and for that we need to produce more, the production has to be more in the same land, and for that each and every parameter has to be looked into, whether we are talking of seed, we are talking of fertilizer, where you are talking of the chemical, everything, the machine energy, the fuel energy, everything that we are talking of has to be minimized or optimized to the extent that we maximize the output and minimize this. Now, this can be done today, this is only possible if you have the high grade sensors or high grade technology which is already available today. The farmer should be in a position to understand which technology I should take, and in fact, it should be an affordable technology. Now, through this example you have seen that how by using simple ultrasonic sensors, these sensors which are already available in the market, they can be put together, the solenoid bulbs are available. If you can put together and cost of another 10-15,000 more, you are in a position to save about 40 to 50%. So, if you take the whole economics over a period of time, then you see that this system is very, very economical and the input will be too just as required. So, these are the things which need to be utilized. So, high technology has to be employed for all these operations. Now, we close here so far as the ultrasonic sensor is concerned. We will also in our earlier next lecture, maybe we will be talking of what is the other technology which can be used. We have various types of technology, what can be used for some other aspect, but always we need to understand that this technology must be within the reach of the farmer. So, there are double you can say the challenge to the agricultural engineers, while they are not equipped with the electronics knowledge which they have, but then they need to take help of their the technology, and then they have to think of how they can utilize this knowledge. So, and the effort is going on in this direction. If this integrated approach is allowed, then it is possible that we can use this technology, high technology which is available, and use for all sorts of operations, not only spraying. We can also think of minimizing the fuel which is being applied. We can also think of the we had talked of in the earlier lectures, if you have followed my lecture where we talked of nutrients. So, if you can online, if you have information about online nutrient availability in the soil, and you can apply through that, you can use through GPS or through the embedded systems. We have talked of this. So, what is important is that the modern technology needs to be implemented into design of machines for agriculture, which will help in minimizing the input cost and then maximizing the output. Now, with this I think we will close here, and then if you have any other questions, we will definitely welcome, and queries etc., which you would have, and thank you very much.